Good afternoon, everybody. My name is Avichal Malhotra, and I'm a research assistant at the Institute of Energy Efficiency and Sustainable Building. Today, I'll be presenting the tool CityBIT. It's a building interpolation tool for energy performance simulation and other applications. Now, the first question that comes to mind when we are talking about CityGML, at least for the people who did not work with CityGML that much, is what is CityGML? CityGML is an open XML-based format that defines the geometrical, topological, semantical, as well as the appearance properties of the different city objects. It's based on the ISO 1900 family, the Open Geospatial Consortium, and the W3C Consortium, as well as the Web3D Consortium and the OSS standards. There are many different available external redefinable dictionaries and code lists that provides the allowed values for different attributes. For example, the different roof types, or it could be the different building usages. These things can be defined in multiple code lists, along with different, depending upon the detailing. Models can be defined over 5 levels of detail, starting from level of detail 0, where you just have the base model, level of detail 1, which is basically an extrusion of the LOD0 model, LOD2, where you have the different roof surfaces as well, level of detail 3, you even have the window properties, as well as level of detail 4, which contains the city furniture as well as the other attributes of the different buildings. As CityGML datasets are really complex, it's huge. So we try to sample out a small dataset which could be identified as a small city quarter, which we try to analyze and see how many buildings are there, how many building parts are there. So for example, the dataset what we selected, there were in total 2,400 buildings, almost 2,400 buildings, as well as 2,700 building parts. But when we look closely, there are in total 1,838 buildings which are defined as tenement building, as well as 380 buildings, as well as one residential building. If I just talk about Germany, because I take the data sets from Germany, almost 20% of the data models which are openly available, it's in level of detail 0, which is just the base model. Almost 30% or 25% are available in level of detail 1. But the most commonly available open source CityGML data model is in level of detail 2. And this is why we created the tool CityBIT in context of in order to develop new CityGML models in level of detail 2. There's again one problem we often face when we are talking about open data. It's many times it's inconsistent. Often it is provided by state authorities or governmental organization. The update schedules lead to multiple discrepancies between the models and the building. For example, as an example here, if we see at CityGML model from 2018, it's a building which is defined there. In 2019, the building is not even defined inside. Yes, that's the true status of the building today. But if you compare to Google, the building is still there. If you compare to S3 GIS visualization, it's not there, and the OpenStreetMaps, it's still there. So it's a lot of confusion and a lot of different discrepancies what people find in open data sets. How do we overcome that? How do we overcome the problem of creating new building models when we want to simulate them? Again, there's some data which is again inconsistent in context of open data. We take an example building. It's, to be very frank, it's near to my house. So we physically went there, tested out the building, and compared to the building model what we have. So you see on the left figure, the physical appearance of the building seems to be fine, just like the other ones. But in the CityGML models, the roof is almost closer to the ground. To have a bigger picture, to look at a bigger data set, we analyzed the data set in Aachen. So in the data set, we see the different discrepancies between the different modeling years in context of number of buildings, number of building parts, the coordinate reference system, the level of detail, as well as the CityGML version. One thing which is important in context of building up building models or modeling building models is the roof surface, because that is normally taken into account when you're calculating the volume of the building for energy simulations. So in this data sets, almost 1400 buildings were with a flat roof, 939 buildings were defined as garbled roof, which is most commonly here. If I look at a bigger picture in the whole city, I would say flat roof and garbled roof are the most common roof types which are available. Looking closer, we again selected the same example what I showed you before, because we can physically inspect that place. We can go there and see how the actual land looked like. So we selected this particular part, which is highlighted in blue here. From 2018, as I previously mentioned, the CityGML model did contain the building there. From 2019, there was just a small part, but we modified for a better building creation using the tool. We even contacted the site. We even contacted the architects which are building the this particular building block, and we were lucky enough to get the site plan. Try to overlay with the CityGML model in order to see how exactly can we create the models. So create enough of the basis. Now I go to the tool. This is the main reason why we created the tool CityBIT, which is a CityGML Building Interpolation tool. Now the question is, how can we create city building models? How can we create 3D models? How can we simulate them when even the data is not existing? So there are two ways to do. One is to use manual inputs, which I'll be explaining in the next slides, as well as the interpolation methods. It could be done on the number of buildings, radius, polygon border. This would be, again, I'll be explaining in the next slides. CityBIT is developed and tested using Python 5. The interpolations which we use are using a SkyPy. The other libraries, for example, NumPy, Matplotlib for plotting, Pandas, LXML, PyProj, which is again a library in Python, which you can use for coordinate reference systems to transfer the coordinate reference system from one zone to another, and the UUID, which creates new unique identifier for the individual buildings, and the main graphical user interface, which is easier for the user to use using PySide 2. So how do we do it? In CityBIT, the model creation takes a couple of inputs that the user needs to give. One is the coordinate reference system. Second is the ground surface. Either it could be the list of coordinates from the user or maybe a center point. Based on the center point, if the user inputs only a center point, the side ratio, the area, and the building heading is asked by the asked to the user. Then the user needs to select which kind of building or which kind of roof type he or she needs in context of building up the model. The height of the roof, the orientation of the roof, these things are also included in CityBIT. Then comes the surface side, the terrain intersection, which is again important, building function, building height. All these parameters need to be added in the tool. Now, it could be added in the tool, or many of them could be interpolated as well. I'll explain it to you in the next slides. So if I talk about CityBIT in context of manual inputs, we took the same example. We added the CRS 25832, which is common for Germany. The terrain height as 161 meters. This is some data we got it from the architects. The story below ground to be like one basement. Story above ground, it's a larger building, so 6 stories. Height of the stories 3 meters each. Building height to be 21 meters, and the roof type to be a flat roof. Using the tool, we were able to create the building models here. But this is only using manual inputs. Coming to the interpolation. So in the tool, we do the interpolation 3 ways. One, using linear interpolation, which is a method of curve fitting. using multiple linear polynomials to construct new data points within the range of a discrete set of known data points. The second one, nearest neighbor methods, which is a method of sampling multivariable interpolation in one or more dimensions by deriving estimates of the surface height at the vertices of a regular grid from irregular space samples. Third, cubic interpolation, which is a method that offers true continuity between the segments and requires more than just two endpoints of the segment, but also the 2 points on either side of them. Now, if I talk about CityBIT, the interpolation and the dataset simplification is quite important, at least for the surfaces where the shape is irregular or just creates a different kind of polygon. So in CityBIT, the buildings are treated as data points at the center of their respective ground surfaces. Some parameters are directly specified in the building models, for example, the building height, while the others can be calculated as well, based on the buildings which are surrounded. The geometry of irregular polygons is simplified to their minimal bounding rectangles. For example, if we take a shape which is not proper polygon or not proper rectangle, the tool simplifies it into a minimal bounding rectangle, and the long side as well as the short side is calculated. To reduce the computation time, the datasets used in interpolation can be restricted or filtered. One, by only considering the buildings of same maybe roof types or building functions. For example, if you want to simulate a building or if you want to create a new city model with the same roof types, you can even do that using CityBIT. The second is by their geographical location, and that could be done in three ways. One, with the number of buildings. If you select maybe 100 buildings to be interpolated, or one building to be interpolated out of from the neighboring 100 using the radius parameter or the polygon border. These things could be selected in CityBIT as well. So using the interpolation, we tried to create new building. As an example, we took again from the city of Aachen, we took a small section. With the CRS, we inputted the ground surface, the center point we have to provide, the interpolation radius to be 100 meters, interpolated value to be terrain intersection, interpolated values which were, the values which were interpolated in the tool were terrain intersection, ground surface, building height, building function, roof type, story below ground, stories above ground, as well as the roof type. Here, we were able to construct the building or build the building model within the whole data set. If I compare the different computational time for different data sizes, for example, if I take a radius of 100 meters, the time in seconds would be 147 seconds. And if it goes on to like 50,000 meters, it's not much, it's still 2137 seconds. Using CityBIT, we were able to even create a small district. It's somewhere in Germany. Unfortunately, I cannot open up the whole coordinates, but yes, we are trying to simulate this building, these buildings. It's almost 112 buildings with one non-residential building and 111 residential buildings. There's a new functionality as well in CityBIT, which is to combine. For example, if you want to create new buildings in a city quarter or in a data set of a city quarter, this is the area. This is also an example given in the paper. And these are the three buildings which we would like to generate using CityBIT. So using the combine functionality, you can create plus combine the whole data set together into one. With this, I would like to conclude my presentation that CityGML users from various backgrounds can integrate newly built and planned buildings into existing 3D CityGML representation of the different city quarters. Develop new building models for existing city quarters without the necessity of explicit modeling, which is quite tricky. CityBIT exports LOD2 building models in CityGML version 2.0. There's a user-friendly graphical user interface and a modular structure of the toolbox. It can be integrated with other tool chains and workflow. Lastly, but most importantly, it's available as open source under the MIT license. However, in future, we would like to compare the sensitivity of the various parameters, qualitatively analyze the interpolation techniques for the generated models, incorporate visualization function of CityGML models into CityBIT, and to integrate district level model creation as a single tool, as a single operation within the toolbox. With this, I would like to thank you for your attention and please ask questions.